All right, target 6 notes. I realize, and when I teach this in class, I definitely put some things on the board talking about the concept of being able to do things in your head. So I realize that when you're doing these notes, target 6, that you're going to be able to do a lot of this in your head. But I encourage you to listen carefully and try to practice the steps to solve it, because there will be some eventually that you can't do in your head. But I don't require that you show work when you can do them in your head. But so keep that in mind as we work through these. When you're solving problems, when you're solving any equation, such as square root of x plus 1 equals 16, or sorry, equals 3, you can figure out that the answer would be 8, because that would add 1 to make 9, and square root of 9 is 3. But what about solving something like 2x plus 1 minus 3 equals 5? Well, you might even be able to do that one in your head. But eventually there's going to be one you can't do in your head, and you need the steps, which would be isolate the square root, add 3 to both sides, then square both sides, etc., etc., etc. So keep that in mind while we're doing these notes. Part 1, solve exponential equations. Step 1 would be write them using the same base, and step 2, set the exponents equal. So number 1, I know everyone can look at that question and say x is 2. And you're thinking, why have you talked for so many seconds now before you tell us that answer is 2? But again, stay with the theme. They're going to get harder. If you write that as the same base, which would be 6, 6 to the x, 6 to the 2, you can set your exponents equal. So x is 2. So number 2, same thing. 6 to the x plus 1 equals 6 squared. If the bases are the same, the exponents are the same. So x plus 1 equals 2, and x is 1. Number 5, if you rewrite 5 to the x plus 1, if you rewrite 1 over 25 with the base 5, which can be done, what exponent would that be? Let's see, it needs to take 5 from the top to the bottom and square it, so that would be a negative exponent. So your answer, x plus 1 equals negative 2. Subtract 1 to both sides, negative 3. I would encourage you to pause the video at this point and try 4, 5, 6, 7, 8, just to see what you can do on your own, and then start the video back and see if you got them correct. So pause it now. Hopefully you paused the video and tried them yourself. But number 4, the common base would be 1/2. And if you rewrote 1 over 8 as 1 over 2 to the exponent blank, hopefully you realize 8 was 2 cubed and 1 is 1 cubed. So you could write that as 1/2 cubed. So your bases are the same, your exponents must be equal. So subtract 1, x is 2. Hopefully by now you've realized that 8 and 125 are special numbers. That's 2 cubed and 5 cubed. So when you go to write this as the same base, 2/5 to the x minus 3, you can rewrite the right side as 2/5 with an exponent 3. Cube that fraction. So your bases are the same, your exponents must be equal. So x is 6. The last 3 here are the ones that start to challenge your mental math probably, if the others haven't already. So when you're thinking 4 and 8, think 2 squared, 2 cubed. When you're thinking 4 and 16, you can think 2 squared and 2 to the 4th, or you can think 4 to the 1, 4 to the 2. So you have options of writing number 7 using the same base. You have the option of base 2 or the option of base 4. In number 8, 16 is, it's 4 squared, but I can't write 8 as 4 to the anything, really, without involving a fraction. So I'm going to use base 2, 2 to the 4th, 2 to the 3rd. So I'm going to rewrite. Step 1, rewrite both bases using the same base. Go ahead and work all of these at the same time. All I've done is put empty parentheses where there is a number. And now, we said in number 6 we were going to use base 2, 2 squared and 2 cubed. So 2 squared, 2 cubed, that represents the 4 and the 8. In number 7 we said we had options of base 2 or base 4, but we're going to use base 4. 4 to the 1, 4 to the 2, that represents the 4 and the 16. The exponents that were originally attached to them are still attached to the parentheses. Number 8, rewriting 16 using base 2 would be 2 to the 4th, and 8 would be 2 cubed. All right, so what does the exponent rule say to do when you have a exponent raised to an exponent. I'll remind you x squared cubed. It says multiply your exponents, x to the 6. So 2 times x plus 1 would become 2x plus 2. Again, multiply your exponents. So you'd have base 2 to the 3 times x, and those are equal. So the bases are the same. That means the exponents must be the same. 2x plus 2 equals 3x. Subtract your 2x, and x is 2. Number 7, power raised to a power, so 4 to the x equals, multiply your exponents again, 4 to the 2x plus 2. Set them equal. Your exponents are x equals 2x plus 2. And then subtract. You got 2 ways to finish solving. I'll subtract x to both sides, so 0 equals x plus 2. And then subtract 2. So negative 2 equals x. Number 8, power to a power. So 2 to the 12x equals power to the power 1, so 2 cubed. Bases are the same, so set your exponents equal. 12x equals 3, divide by 12, and x is 3 divided by 12, also known as 1/4. So that is part 1, and I'll go ahead and break this video up into 2. That is part 1 of the notes, solving exponential equations. Part 2 of the video will be solving logarithmic equations. So, second video to come.